All right, the pattern is in the flask, and as I can see, you need to have about 1 inch of sand all the way around. If it's less than that, depending on the part, how hot it is, what will happen is it will burn the flask. The grooves are in here just to help the sand stay in, so when I flip the flask over, I won't lose the whole lot of sand and have it slip out. I've never had it happen, but it can. This part, unfortunately, it's got a lip on this side here, so I'm going to have to pack a little bit of sand around it when I first get started, then ram the rest of the sand all the way around it, strike it off, and turn it over. And then once it's flipped over and this is now on the top of the flask like this, what I need to do is clean out this area and then chamfer it back a bit and install the tang that has to be put on, dust it, and then what I'm going to do is put the other flask on top and ram the sand on it, remove it, and then I will cut the I'll put a vent in it, and I'll put the sprue in it as well. I put the sprue in after. Some guys put a dowel and then they pack the sand around it. I've got a piece of very thin stainless steel tubing, only 10 thou wall, and I can push that right through the sand and make my sprue that way. Okay, so I sifted the sand yesterday, and this is Petrobond sand, and to activate it, it's been sitting for quite a while, this sand. I've had it for 10 years, and I've had it all closed up and stored up. So what I'm going to just do is push a little bit around the underside so it doesn't collapse when I take it apart, and flip it over. And to activate the sand, especially if it starts to dry out, we use a little bit of white gas, which is naphtha, and that causes the oil to want to bond. This is only for aluminum. You can't use this for steel. Steel is it's too hot, and you'll lose the sand in the process. Okay, so that's got it started, and I'm just going to continue and shovel in the sand. I'm hoping I've got enough here. If not, I've got some more in the basement I'll have to prep up. But I'll put a little more in just so it doesn't want to slide around. I've got it on a piece of white, actually it's peel and stick white plastic, and the intent of that is it just keeps the work area cleaner for me. It can get kind of gritty and ugly. And then for ramming, that's all. This is a piece of 2x2, and I rounded the handle off a bit. And it's just a matter of going around and initially starting to tamp it in. And you make it in layers until you get till the flask is full, and then you strike it off with a straight edge. So when you strike it off, you can use anything. I'm just using a piece of aluminum angle that I had laying around the shop. If you have a low spot, you can push some of it into there. I'm trying not to make a real big mess here because this isn't a dedicated casting area. It's actually the top of my table saw. So anyways, this is going to be the bottom once it gets turned over, and that's what it should look like. Okay, with that striked off, what I'm going to do is just flip the pattern and mold over, or mold and pattern, whatever way you want to look at it. And as you know, I can't get this out because I've got this ridge all the way around. So I have to trim it out with some little tools that I have, and I'll show you how that goes in a minute. So these are a bunch of artist tools that I got on eBay, but they're quite handy for what I want to do here for cleaning out the sand mold and making it a little bit customized for what my application is. So it's just a matter of spending some time. I know it looks tedious, but it's because of the pattern. If it would have been flat, then that would have been great. I could have just closed the mold and put the sprue through it and the sprue through it and be done with it. But in this case, I can't. So I'm just going to mess around with this and get it prepared. Okay, so what you see now is I've chamfered or beveled it back because I want the other mold to lift off and not just have a little piece in here. The other part of the mold, the sand is going to be right up to this level here. This is going to be flat because it's the top. So when I break the two apart, I don't want this little piece to fall apart. I'm hoping I've got enough, but if it's not, then what I'm going to have to do is try it again, clean it out and give it a shot. So now we're at the point where some dusting happens, and basically this is just some talcum powder and a little bit of the bentone clay. I think it's bentone. It's been so long I can't remember. And we just make sure that it's dusted. So this is going to stop the other layer of the clay or the sand from attaching to this half of the mold. One's called a cope, one's called a drag, and you think I can remember which one's which? No, I can't. Another point that has to be done is you need at least 4 degrees, 2 to 4 degrees of chamfer, so that the parts will come out. If it doesn't have that relief on it, if it's square, it's going to get caught. So now I'm going to just gently start adding some sand into the top half of the flask. Not going to get too crazy here. I know I'm going to have to go get some more sand that I didn't sift, but it's only going to be here to fill the flask. It's not going to be necessary to take the shape. I had some bigger flasks, and of course bigger needs more sand, and do you think I could figure out where the heck I left them? I have not been able to find them. So anyways, I'll continue on with this, and the next thing you'll see is the mold completely done. Meanwhile, while I'm doing the casting of the pattern in the sand, I have the melt going to start. I've got the stove going, and you can see there's an old coal scuttle or scoop there to the left. Got anthracite cold. My melting crucible, which is actually made out of steel, is directly in front, and I have a lifting device that I can move by hands, and I can melt up to 20 pounds of aluminum in that crucible. We'll put the lid on top of it, and as it keeps once it starts to melt, I keep putting in pieces of old, some of them are car rims, some of them are cylinder heads or brackets off of aluminum parts off of cars, and the dirt will come to the top, and I'll skim that off. I've got a little skimming tool, and once it gets hot enough, I'll degas it, and I'll get set up for the pour. Well, this is my scrap metal pail. I've got other pieces around, but that's what I'm working from. Over here is the stove. Give you a little look inside. It's glowing red down at the bottom, and it's got a 5/8 steel bottom, so it shouldn't be long before that starts to melt, and I'll put the lid back on it as well. Okay, well, because that part is so small, it used up all my sand, which is considerable. And I forgot to put this tang, which has to go in on the pattern. So instead of taking this all apart again and redoing it, what I'm just going to do is take one of the small trowels that I have here that I've been using, and I will cut out the void for that in the pattern or in the sand mold, and it should be okay. It's a tang, it's on the inside, you don't see it, And if it's a little too big, well, I'll machine it or file it or whatever to bring it into size. So as you can see, I lifted this off straight up, flipped it over, but part of this had stayed behind. It's in the picture, and this has now been damaged. So what I'm going to try to do is just repair it here. You can see how I've ramped it up so it wouldn't have some strength. If it was just this little bit, it probably would have pulled away. So I'm going to try to repair that, and then I'm going to cut the gate or the sprue through the center of this and go from there. We'll see how this works out. If it doesn't work out, I'm going to end up having to redo it. Well, third time it tore out, and I've now cut it out bigger, hoping that's going to give it more strength to pull apart. It's been a challenge. I did put the little block on here. It was fine, but this end here, for some reason, when it pulls apart, I part the mold, it gets caught and damages it. So I'll try it again. In the meantime, I'm trying to melt my aluminum, and normally you have I have the mold already. Just waiting to deal with the aluminum, get it ready to go, and now I'm kind of jumping between both, so always a challenge. Well, still I had some trouble over at this side. Maybe I don't have enough draft on it, but I managed to fix this one up a little bit. It had a couple spots. It should be okay. I might have to touch it up with a file after, but that won't be a big deal. But I'm almost there. My aluminum for some reason isn't melting, so I have to contend with that as well. But we're just about here, ready to remove the pattern, and it's not real complicated. It's basically what you do is, of course, I could have problems with that too, but anyways. Yeah, if this doesn't come out, then I'm in real trouble. Such a shallow pattern, I would have thought I wouldn't have, there we go. Ah, shoot, look at that, it's stuck. Okay, well, I should be able to fix that with a little trowel, and the rest of it should be okay. Okay, I managed to repair it with these two little trowels, a little bit of sand, and smoothed it in and packed it down. So we should be good to go to close the mold again. I've just got to put the sprue in first. Well, we'll see if this goes the way it should go, but normally all I do is I push this thin pipe all the way through, nice and gentle, turn it a little bit at the bottom, and then I pull it straight out. And that's going to give me the gate for the aluminum to flow into the mold. I should be okay. Maybe I should put a vent in on this one, just with a piece of tungsten, TIG welding tungsten, just to put a small tiny hole in there, so if there's any air, it's going to vent out and let the aluminum flow in. So I just took a 16th tungsten, push it through the sand all the way to the outside, and now I'm just pulling it back out. And that will be my vent. So when the aluminum goes in there, the hot gas and the air have someplace to go. So as of now, I'm ready to put the mold down on the casting mat, which is over here. And the reason I use a sheet of tin is in case it spills. When the hot aluminum hits, the molten aluminum hits the floor, it tends to explode because of the moisture in it. So the tin acts as a heat barrier and prevents that from happening. So this piece of pipe is going to be my funnel, and what I do is, again, I take this and go through, give it a gentle turn. And then I just go take a trowel and I just carve it like a funnel. And there's a funnel that's going to go on top of the flask with the sand for the mold. Okay, the aluminum has been skimmed and degassed with sodium hydroxide, and I'm ready now to pull it out of the fire and do the pour. So I've got a pair of fireproof coveralls on. Come on, get out of the way. And I'm just about ready to do this. It's a two-handed job. I'll go the other way. That hooks it. And now, it's certainly easier with an extra person, but, and then what we do here is the leftover, I just throw it into here and make an ingot, and that's it. Now, probably in 20 minutes or so, that would be hard enough, set up enough, maybe not even, that I could dig it out of the sand. But the issue I have is, just like what you see right now, whatever was inside this before is burning and filling my shop up with smoke, and it's not really nice. So if I were to dig that sand out, it would just be so full of smoke. So I'm going to let that sit either till tonight or till tomorrow, and I won't have to deal with it. But it's always essential to have at least 6 inches of head pressure so that the aluminum will flow into all the little crevices in the mold. And we can see how it did fill to the top. I had some left over, and it's contracting a bit. Now normally it'll contract about 2%. That's the difference between molten aluminum and once it sets. I had some muffin pans, and that's what I would normally pour this into, is into a muffin pan, and that would give me nice little ingots that I could take out. However, as this shrinks, it should come out anyways. And that's it, folks. Well, we just started digging out the sand from the flask on the top. It's still a little bit warm, but it's not so hot as it will smoke. You can't touch it with your hand, it's still too warm, but hopefully we'll get down into here and see something. Well, there's something. You can see it. I'll have to put a glove on because I can't hold it. It's not super hot, but it's hot enough that you can't hang on to it with your hand. Okay, well, I've shoveled out quite a bit. I've got just some kind of a glove on right now, and there's the part. Of course, the funnel, it's kind of caught in there. As I knock it out, clean it out. Well, it don't look so bad. Maybe a little bit of touching up with a file or a rotary Dremel tool. I might not be in too bad a shape. So I've got it out of the sand mold. It's still a little bit warm. I can just barely touch it with my hands. Rougher than I expected, I think, because I had to touch it up. And there's some places here I'm going to have to either take a little rotary burr or a file or whatever, clean that down. I knew I was going to have to notch this out. That's part of it, and maybe take a little bit of that out as well. But this side here, it looks like part of the mold broke away and left a void in the mold, which fills up with aluminum. The other side, well, again, as I've said, it's not as good as I've done in the past. I've got a void in here, a pocket. But seeing that it's a cover, and I'm going to file it a little bit. I mean, I could always get the TIG welder out there and do something, but I think what I'll just do is give it a little skim with some body filler, and it should be okay. Well, I did a little bit of cleaning up here with a Dremel tool and a carbide burr. Just took off some of the high spots. As you can see, I got a pocket here. I'm going to just put a little bit of body filler on that just to kind of pretty it up. And I haven't cut the sprue off yet because it actually made it easier for me to work on this. And then what I've done is I have drilled through there. Whoops. I have drilled through there so I can cut through with the tang. I'm going to have to do a little bit of removal in here. I'll do that in a minute. But overall, it isn't bad. A couple of problems with the casting. It's not as smooth as I normally would like it. Normally it would be more like this. The sand has sat for a while. I didn't dry it out. I possibly should have dried out enough just to pack around here. And the other thing I had, the other problem with the sticking, I forgot to dust the front of the pattern before I placed it down and started to ram the sand. So, you know, it's been a while since I've done this, and you know, live and learn. But well, all in all, I think it'll work out okay. It'll be nice. And little cast aluminum cover for that Ammco 6-inch metal shaper. Okay, so we ended up finally getting this piece to fit. A little bit of filing and shaping, and it's got a tang on the bottom. Maybe I have to give a little bit more. You can see here the clearance. The issue at hand is at the bottom, the casting is 570, and at the sides it's only 550, and that's how close I've got it filed. So I'm going to touch it up a little bit more, and that should get it, and then I'll work on the latch. Well, as luck would have it, I made this a little too thick. I went based on the thickness of the casting, but there's a nut on the inside that changes the stroke. And when I fitted this up, just touching it, of course, guess what? It's making a line. Not much, but I put a relief in here, maybe about 50 thousandths of an inch, and hopefully that will be enough that I don't have to put it in my milling machine and dance around all this to face it back. So we'll see.